All right, hello and welcome to the next video for 8.5 imaginary and complex numbers. We're still dealing with just what we call purely imaginary numbers, meaning they don't really have that not imaginary part, right? They have real numbers in them, but things like 3i, 6i, stuff like that. Alrighty, remember that I, is equal to -1, square root of -1, and therefore I squared would be a whole -1, okay? Then this is where I is really important. I is a thing that doesn't exist. It's not a real number. But when we apply a rule to it, it becomes a real number. And that is something that needed to happen. And that is why we brought about I in general. The only thing you want to be careful about is when you're multiplying with radicals and you're dealing with this I, you need to be careful because what you start with is not a real number. And the things that are not real numbers are going to cause a few loops. Remember, all the real numbers have to play by the rules. They are bound by universal law. If two things multiply, it's going to be the same thing anywhere in the universe. Imaginary numbers don't have to follow that rule. Imaginary numbers are not real numbers. They are not a part of that group. And so they kind of break the laws a little bit. If you take a look at this example here. Now, if we had no negatives in this problem, and we had the square root of 4 times the square root of 9 versus the square root of 4 times 9. Here we see this would be 2 times 3, aka 6. On this side, we see the square root of 36, also 6. And therefore, we could say these are equal. Now, that should be a universal law. We've proven this. We've used this in the last couple sections. We've used this to make our life a lot easier with variables. However, when all of a sudden your things from the beginning don't exist, they don't follow that rule. If I have the same problem now with -4 and -9, we can see on the one hand, if I try to put those, or if I do separate individual items, I would get 2i and 3i, right? So let's copy paste this problem over here. It's a little easier to see. -9 and -4 times -9. So over here we get 2i and 3i. When we combine those together, we get 6. Multiply the i's, you get I squared. And I squared is equal to what? Well, if I squared is the square root of -1, I squared is -1. So we've got 6 times -1 or -6. Over here, if we do this side, we multiply these from the beginning, we get a positive 36, and therefore we get a positive 6 out of the square root, and those do not equal. So we get a sign issue here. So we have to be careful about that. We have to do the I part first. We kind of have to fix the first problem that these two numbers don't exist, and we would in fact go with the negative version. This would be the correct PEMDAS version. Okay, so it's just another PEMDAS idea. But let's try this out a little bit more. Here I've got the root -3 times root -7. First issue is that neither one of these things actually exists. There is no square root of -3. There is no square root of -7. So let's go ahead and adapt this and pull that negative out. Okay, these two are going to become i's. The other two are not going to simplify, but that's okay. That's okay. Now I have I squared, √3, √7, and see how they're positive now? Now I can put them together, and I get I squared is -1 times √21. In other words, -√21 would be my answer. So you can combine them that way. Notice it is not √21. Okay, it is not √-21. Trying to make a trick out of this is going to make you put the negative in the wrong place. So let's try it again. Let's go over here. Let's just go step by step and take out that negative from the beginning. Square root -1 times square root 2, square root -1 times square root 8. And if you feel comfortable at this point not writing square root of -1, but just taking it out as an I, that's fine too. Again, I like saying take out the negative, but that's just me. Oops. These two i's are going to become I squared. These two are going to become 16. I squared is -1. What is the square root of 16 now? Not square root of -16 or positive 16. It's going to be a 4, and I get a -4. Very similar to this first purple example we did up here. But notice, neither one of these actually started as a square, right? Whereas in the first one, 4 and 9 are both squares. So you have to make sure that when you multiply, you consider that square at the end as well. All right, looking at a couple other examples. Here, there's only one that is imaginary, but still we want to fix that problem. We don't want to combine things that are not alike. I have fixed that problem now. They are now alike. And we have I square root of 30. Square root of 30 does not, in fact, simplify. If I break that apart, it's a 5, a 3, and a 2, and I have no pairs. So this would be my final answer. All right, now this last thing, it also, sorry about that, applies to the division rule. If you recall, the division rule says we can combine these guys into 75 over 3, but that's only in the positive case. Again, we see that this thing we have, this division, this fraction, is not real. This fraction doesn't exist. There is no square root of negative 75. There is no square root of negative 3. And so this is the problem that I must fix first. I must try my very best to make this as real as possible. In other words, I over, or square root 75 over I root 3. So fixing this problem is not complicated, but it's important to remember it's a problem to fix. And in fact, the i's are going to cancel. And so what I'm left with is a positive version. This is very similar, but not exactly the same as the canceling of the i's inside the parentheses, canceling of the negatives, pardon me. This is similar to a negative over a negative deleting, but it is not exactly the same, and you have to be very careful with it, okay? Because you're not always going to get that happening. We have 75 over 3 now. Because it's positive, I can apply this rule without worry. And 75 divided by 3 is 25, which we know is a classic 5. So the two things that were not real ended up dividing out to a positive whole number. Let's do it one more time. Again, we have something that is real underneath something that is not, and so that is the thing I want to fix first. I'll just take out the I. And from here, we have a little wiggle room. We could simplify the top, simplify the bottom, see what cancels. We could apply that double square root rule, work with one fraction. I think in this case, since 32 does in fact simplify with 8, I might go with that. In just a moment, I'll show you how to do it the other way. I'll do both just so you can see. Here, what do I do with the I though? The i's on the outside. It's not canceling. It's still here. I'm going to go ahead and pull it out of the fraction altogether. It is now chilling on the outside. I have I square root of 4. In other words, 2i. Okay, that was not my only option, though. I could have left the I. If you weren't comfortable taking that I out, you could take 32 and simplify it. 4 and 8, 4 and 2. So 4 root 2. Over square root of 8 is 2 root 2 via the same method. 2 and 2 and 2. And that's just a scribble. We end up seeing a pair of 2's, and then these 2 would reduce to a 2, and these 2 would cancel out altogether. And again, we see a 2i. All right, either way is totally fine. Remember, PEMDAS is up. PEMDAS within multiplication and division is up to you, and that's why this rule works in general. So be cautious about it, but always take care of the I first. The next topic we're going to talk about is complex numbers. We're going to start combining these real things and these imaginary things, and I will see you there in the next video.